Okay, right, the title of this video is number sequences, keywords, term to term, nth term, and position. A couple of objectives, find the nth term of a sequence, and also to find any term in a sequence. A personal learning and thinking skill, independent inquirer. Hopefully you'll be able to spot patterns and describe them. Okay, we're going to start off with a simple little example and hopefully build on that to something a little bit more challenging. Right, let's call this example 1. Let's use a different color. And we have 2, 5, 8, and 11. Okay, now that sequence could carry on as long as I wanted it to. I've just done the first 4 terms in this sequence. Right, looking at those keywords, the first one was term to term. A term is basically just the number in the sequence. So that's the first term, second term, third term, fourth term, and so on. The term to term pattern describes going from one term to the next, one term to the next. And you've probably already seen that there's a little pattern there. We'll come to that in a second. The other keyword was nth term, and nth term is something we're going to find in a minute. The last keyword was position. The position is basically where it is in the sequence. So that's the first position, second position, third position, and so on. Right, coming back to that second keyword, nth term. The nth term is what we're going to try and find for this sequence. And the nth term basically just is a description of the sequence. It describes that sequence. Not only does it describe it, but it also gives us a way of finding any other terms along that sequence that we're not given. So let's say if I wanted to find the 50th term, I could use the nth term, which I'm going to find in a minute, to help me to do that. Right, now in order to find the nth term, in order to describe this sequence, what we need to do first of all is to spot a term-to-term pattern. Now you can see straight away, hopefully, that there is a term-to-term pattern here, and it is that it increases by 3 every time. So that goes up by 3, that goes up by 3, and so on. And we can assume that this sequence continues to go up by 3 every time. Now, that helps us to describe the term, describe the sequence rather, and to give the nth term. Now, there's also something else that goes up in 3, and that's what's going to help us to give the nth term, and that is the 3 times table. So if we just quickly write the 3 times table over here, and I'm not going to write all of it, just the first 4, so you can see that the 3 times table also increases by oops, 9. That wasn't too good, so I should rub that out. Increases by 3 as well. So there you go, 9, 12, increases by 3. You can see that very clearly there. It goes up by 3 every time. So there's a relationship between the 3 times table, or the answers to the 3 times table, and our sequence. The relationship is that our sequence increases by 3 every time, and so does the 3 times table. And again, I could have carried that on as long as I wanted to. Now, in order to describe our sequence, we've first got to be able to describe the 3 times table, and you probably already can. It's called the 3 times table. Another way of describing it would be that it's always 3 times a number, or any number. So this number could be any number I wanted it to be. Another way of writing that, as we often do in maths, instead of any unknown number, we can write a bit of algebra. So we can say the 3 times table is 3 times any number. We'll just call any number n. And also in algebra, we don't usually write the times sign because it can get confused with the letter x, which we often use in algebra. So we can just call the 3 times table 3n. And that's just a description of the 3 times table. So the 2 times table would be 2n, 2 times any number. The 4 times table would be 4n, the 5, 5n, and so on. So, in starting to describe this sequence, we can say it's something to do with the 3 times table. So it's something to do with 3n. That would be the first part of the nth term. And the nth term is basically an algebraic expression. That's what we're going to come to at the end of this. Now, you can quite clearly see that this sequence is not the 3 times table. It has something to do with it, because it increases in 3, but it's not, because those numbers are not in the 3 times table. They're not answers, or they're not multiples of 3. So let's just jot down our 3 times table above that, and then compare it. Well, you can see hopefully straight away that our sequence is the 3 times table minus 1. Okay, 6 minus 1 gives us 5. 9 minus 1 gives us 8. 12 minus 1 is 11. So our sequence 2, 5, 8, 11 is the 3 times table less 1 every time, and that is the nth term rule for this sequence. Okay, that's basically how to find the nth term. Okay, right, quickly moving on. I'll give you another example down here, and let's call this example 2, 5, 7, 9, 11, and 13. And again, I've given you extra terms there. I've given you 5 terms this time, but I could have carried that on and on as long as I wanted to. So a bit quicker this time. You can see straight away that term to term, it goes up in 2. I'm not going to write all of them, but you can see straight away it goes up in 2. So clearly the nth term rule, or the thing that describes this sequence, is something to do with 2n. Let's get rid of that. So something to do with the 2 times table, 2n. Now if we write the 2 times table above it, you can see hopefully the relationship between the 2 times table and our sequence is that our sequence is always 3 more, plus 3. 2 plus 3 is 5. 4 plus 3 is 7. 6 plus 3 is 9, and so on. So the nth term for this sequence, the thing that describes the sequence, is 2n plus 3. There we have it. Now, a second question you'll often get asked is, well, first of all, to find the nth term, and the second is to find, let's say, the 20th term or the 50th term of this sequence. What that means is find a term in the sequence that is the 50th one, or the 20th one, or even the 100th one. They could ask you any one. So let's just look at 20th term. So the 20th term, how would we find that? Well, if you think back to what we said about 2n, 2n is the 2 times table. So it's 2 times 1, 2 times 2, 2 times 3, and so on. That gives us 2, 4, 6, and so on. Now, if you look at this second number here, in describing the 2 times table, we said that second number, and we could have written it first, is any number we want it to be. Okay? Any number we want to be could be in that column there. Okay? Now, if I was looking for the 20th number in the 2 times table, I'd do 2 times 20. And I would, of course, get 40. So that n will be replaced by 20. You can also say it's the position, because the other keyword we looked at was the position. So the first position, in first position, is 2. In second position is 4. In third position is 6. In 20th position is 40. So in our sequence, the term that's going to be in the 20th position, n, is going to be replaced by 20. So 2n means 2 times 20. So it's going to be 2n means 2 times n, and it's going to be 2 times 20 because we're replacing the n or substituting the n with 20, and then we're going to add 3. If you remember your rules for BODMAS tells you that you do multiplication before addition. So 2 times 20 first gives you 40, and then you'll add a 3, so the 20th term is 43. Okay? Again, you can pause this video at any stage, go over the examples I've just done, and recap. I'm just going to do one more example. Hopefully you'll be able to do this yourself, so if you want to pause at this stage and have a go at this, brilliant. If not, I'm about to do it now. So here we have and again, I could carry that on as long as I wanted to. So hopefully you can see straight away that it's a simple number sequence that's going up by 4 every time, so it's increasing by 4. And what do you know that increases by 4? It's the 4 times table. So the nth term for this sequence is something to do with the 4 times table, which we can describe as 4n. If we write the 4 times table above that, you can see that it's actually not the 4 times table, and that there's a difference. From the 4 times table, we're always 5 more, so we're adding on 5. So our sequence is the 4 times table plus 5. And if I was to ask you to find the 20th term, again, you might want to pause at this stage. I simply replace that n with 20. 4 times 20 plus 5. Again, BODMAS tells you to do the times before the add. 4 times 20 is 80. 80 plus 5 gives you 85. And one more last example. If I was asked to find the 100th term, I'd just do, instead of 20, I'd do, instead of n rather, I'd just do 100, so it's 4 times 100. Then I'd add the 5. Times before add, 4 times 100 is 400, plus the 5 gives you 405. Okay, right. Quick recap. We looked at number sequences, term to term. Nth term is what we were looking for, and position. Objectives were to find the nth term of any sequence, and I think we pretty comprehensively covered that, and also then to be able to find any term within that sequence. And that is the end of that video, and that's